Good morning. So today what we're going to be working on is page 13 in your packet. For those of you who do not have the packet, please find this attached to the Google Classroom link. And so this is affectionately called the Sarah box in period 1 because Sarah just loves filling this out. Okay, so we're going to review algebraic approaches to evaluating limits. And so we now have different strategies. And so that's what I'd kind of like to review first. The first strategy you guys learned was using a graph or a table. And so this always works. And that's the nice thing about it being the first strategy you learned is you can always just graph your function and see what's going on. You could also make a table surrounding the values from the left to the right of the point you're being asked about. It's not always the most practical because some graphs are hard to make, but it'll definitely always work. The next strategy you learned was direct substitution. Now this strategy is important because whether you have a graph or a table, this will pretty much always work or indicate that you need to do something else. If you directly substitute and get 0 over 0, that's going to mean you need to either factor and simplify, or it's going to mean you need to rationalize or multiply by the conjugate. And in the fraction examples, it also meant that we needed to just simplify the problem and cancel out. The final strategy that you've been taught so far is the properties, the limit properties. And I think we did this in the lesson previous to this one, but this is where we're going to see, as x approaches a of some function, right? As we use this notation, but if we have a constant, what's the limit of a constant? It's just that constant. That's 1. If we have the limit as x approaches a of some c times the function, we can move that c out. And then just evaluate f of x. We also have the limit as x approaches a. If we had two functions, added or subtracted, we could separate those two things. That also goes for division. Just as long as g of x does not equal 0. What else did we have? Oh, multiplication. So if you had the limit as x approaches a of f of x times g of x, you could separate that one. And I think that pretty much sums up those. The last thing I want to put in the Sarah box is what kind of answers you could get. So if you have a number over 0, this is going to be plus or minus infinity, trying to figure out where the graph is going. If you have 0 over a number, the answer is just 0. Remember that k here cannot equal 0. If you have 0 over 0, we're going to try all of these different ways over here to solve. There's also, sometimes you'll see infinity over infinity, and these are what we call indeterminate. And then the last one you could get is a number over infinity, and that would mean that we're going towards 0. Okay, so your assignment for tonight for homework is I'd like you to complete the check your understanding problems and upload a photo of them, and I will post the answers for you tomorrow. Have a great day.